How one farmer's ridiculous tractor mod cleared 300 miles of beach mines June 7, 1944. Omaha Beach, Normandy, France, 6:42 a.m. Lieutenant Thomas Garrett crouches behind a disabled Sherman tank, pinned down 50 yards from the seawall. Around him, the carnage of D-Day's second morning continues. The initial landing succeeded, but barely. Now engineers face an impossible task, clearing the minefields that protect every exit from the beach. A mine clearance team works 30 yards ahead of Garrett's position. 5 men in a line, probing the sand with bayonets, marking safe paths with white tape. It's agonizingly slow. They've cleared 20 yards in 2 hours. At this rate, opening a single vehicle exit will take 3 days. Then Garrett hears the explosion. A mine detonates. 2 engineers are down, one clearly dead, the other screaming. The remaining 3 freeze, terrified to move in any direction. The statistics are catastrophic. In the first 36 hours of the Normandy invasion, mine casualties exceed combat casualties in some sectors. German defenders planted an estimated 6.5 million mines along the Atlantic Wall. The beaches, the dunes, the roads behind them, all transformed into killing grounds that can't be crossed without triggering explosions. Allied engineers use 3 methods for mine clearance. 1. Manual probing with bayonets, effective but incredibly slow. Average speed, 15 square yards per hour per team. Casualty rate, 47% for engineers performing this work. 2. Bangalore torpedoes. Explosive tubes pushed through minefields to detonate mines via shockwave. Effective in limited areas but requires engineers to approach within deadly range. Creates cleared paths only 8 feet wide. 3. Flail tanks. Sherman tanks with rotating chains that beat the ground, detonating mines. Effective, but only 23 flail tanks made it to Normandy beaches on D-Day. Insufficient for the scale of minefields. The result? Allied forces are bottlenecked on beaches, unable to advance inland at necessary speed. German counterattacks are coming. Every hour the Allies remain trapped on beaches, the invasion becomes more vulnerable. General Omar Bradley, commanding 1st U.S. Army, sends a desperate message to Supreme Headquarters on June 8th. Mine clearance is the critical bottleneck. We need vehicle exits off these beaches. Current clearance methods are too slow. We're sitting ducks. Urgent need for solution. What General Bradley doesn't know, what nobody in the Allied command structure suspects, is that the solution to their crisis already exists. It's sitting in a field in Devon, England, where a 53-year-old dairy farmer has spent 3 months modifying a tractor in ways that Army engineers would consider completely insane. His name is William Fletcher, and his ridiculous tractor modification is about to clear 300 miles of French coastline and save the Normandy invasion. William Fletcher was born in 1891 in Barnstaple, Devon, in the agricultural heartland of southwest England. His family farmed the same land for 5 generations. William inherited the farm in 1919 after his father's death, returning from the Great War with a military medal for bravery and a profound distrust of military bureaucracy. The farm was 240 acres of pasture and cropland. William raised dairy cows, grew wheat and barley, and lived the quiet life of a rural farmer. He married Anne Hoskins in 1920. They had 4 children: Robert, born 1921, Margaret, born 1923, Thomas, born 1925, and Elizabeth, born 1928. But William Fletcher had a talent that set him apart from other farmers. He could fix anything. Tractors, plows, harvesters, pumps, engines. When something broke, William didn't call a mechanic. He analyzed the problem, improvised a solution, and usually improved the original design in the process. By the 1930s, Fletcher Farm had a reputation across Devon. When other farmers had equipment failures, they brought their machinery to William. He'd study it, disappear into his workshop, and return days later with creative repairs that often worked better than factory specifications. His workshop was a chaos of parts, tools, and half-finished projects. William's approach to engineering was empirical. Try something, test it, modify it, test again. He had no formal engineering training, just practical experience and an intuitive understanding of mechanical systems. When war began in 1939, William was 48, too old for military service. His farm contributed to the war effort by producing food. 3 of his 4 children served: Robert in the Royal Navy, Thomas in the Royal Engineers, Margaret as a nurse. Elizabeth, 16 in 1944, remained home helping run the farm. In March 1944, William received an unexpected visitor. March 15, 1944, a Royal Engineers captain named David Morrison arrives at Fletcher Farm, driving a military lorry. He's accompanied by 2 sergeants and he looks exhausted. "Mr. Fletcher," "I'm Captain Morrison. I understand you have expertise in farm machinery modification?" William wipes grease from his hands. "I fix things. Wouldn't call it expertise. We have a problem. The invasion is coming. We need better mine clearance equipment. Army engineers have ideas but lack practical implementation. Your son Thomas suggested we speak with you." Thomas is serving in mine clearance units, training for the invasion. He's written letters describing the inadequacy of current equipment and mentioning his father's mechanical skills. Morrison continues, "We need someone who can build prototype equipment quickly, test it practically, and modify designs based on field conditions. Someone comfortable with improvisation." Thomas says that describes you. "What kind of equipment?" "Mine clearance. Specifically, we need better methods for clearing beach obstacles and buried mines. Current methods are too slow and cost too many lives. William considers this. Show me what you're working with." Morrison's sergeants unload equipment from the lorry, a mine detector, several types of mines, and diagrams of proposed clearance systems. William examines everything, his experienced hands testing weight, balance, and construction quality. "Your mine detector is too heavy," William observes. "Man carrying this gets exhausted in an hour. Need lighter materials, better weight distribution. Can you modify one?" "Probably. What else?" Morrison spreads out diagrams showing various proposed mine clearance systems. Most involve complex mechanical devices requiring specialized manufacturing. William studies them skeptically. These designs assume factory production with precision machining. In field conditions with battlefield damage and improvised repairs, these will break down constantly. "That's the problem," Morrison admits. "We need something simple, durable, and repairable with basic tools." William thinks for a moment. "I need to see how mines actually work, not diagrams. Real mines." Morrison hesitates. "That's irregular. Mines are restricted ordnance. Can't design clearance equipment without understanding what I'm clearing." Morrison makes a decision that violates several regulations. "All right, we have a mine testing range in Dorset. I'll arrange access." Over the next 2 weeks, William Fletcher receives a crash course in mine warfare. He visits the testing range, watches live detonations, examines mine construction, and learns triggering mechanisms. He takes extensive notes, sketches diagrams, and asks questions that surprise military engineers. "Why do mines bury at specific depths?" he asks. "Psychological effect," an engineer explains. "Shallow enough that probing with bayonets is dangerous, deep enough that soldiers can't see them." "What's the minimum pressure to detonate?" "Depends on mine type. German S-mines require about 15 pounds of pressure. Telemin anti-tank mines require 300 pounds. William absorbs every detail. When he returns to his farm, he has a complete understanding of the problem the army faces. The challenge isn't just detecting mines or detonating them. It's doing so at speed with equipment that can operate on beaches with soft sand, saltwater corrosion, and enemy fire. It's creating a system that frontline soldiers can operate without extensive training, and it's accomplishing this with materials and tools available in battlefield conditions. William spends 3 days thinking, sketching, calculating. Then he walks to his largest barn, where his Fordson Model N tractor sits idle. The Fordson is a workhorse machine, built in 1927, that William has maintained meticulously for 17 years. It's designed to pull plows through heavy clay soil. It's slow, durable, and simple. William looks at the tractor with new eyes. It's heavy enough to detonate pressure mines. It's simple enough to repair in field conditions. It's powerful enough to operate in soft sand. And it's expendable, unlike trained soldiers. Over the next 6 weeks, William transforms the tractor into something the British Army has never seen. His modification is based on a simple principle: if you can't avoid mines, trigger them from a safe distance. William's design: 1. Extended chassis. He removes the Fordson's rear wheels and replaces them with a custom-built extended axle that positions wheels 6 feet farther back than original design. The driver's seat remains in normal position, but the rear wheels, which bear most of the tractor's weight, are now far behind the driver. 2. Weighted front roller. He fabricates a massive steel roller 4 feet in diameter and 6 feet wide, weighing 800 pounds. The roller mounts on an extended frame ahead of the tractor's front wheels. When the tractor moves forward, the weighted roller travels ahead of the vehicle, applying pressure to the ground. 3. Armor plating. He welds steel plates around the driver's seat, creating a protective box. The plates are salvaged from a scrapped threshing machine. They won't stop direct artillery, but they'll deflect mine blast fragmentation. 4. Remote steering linkage. He extends the steering column forward, allowing the driver to control the roller's direction while remaining protected behind armor plating. 5. Blast deflectors. He angles the bottom armor plates to deflect explosions downward and sideways, away from the driver compartment. The result looks absolutely ridiculous. The tractor is twice its original length, front-heavy, asymmetric, and cobbled together from farm equipment and scrap metal. No military engineer would approve this design. It violates every principle of proper engineering. But it works. April 28, 1944. William demonstrates his modified tractor at the Dorset testing range. Captain Morrison and a dozen Royal Engineers. Officers watch skeptically as the ungainly machine rolls onto the test field. The field contains 20 live mines, buried at various depths and patterns. William climbs into the armored driver's seat, starts the engine, and drives slowly across the field. The weighted roller moves ahead of the tractor, pressing into the sand. When it crosses the first mine, the explosion is deafening. The roller absorbs the blast, bounces upward, crashes back down, and continues rolling. William continues driving, seemingly unconcerned. 17 more explosions follow in rapid succession. Each time the roller detonates the mine, absorbs the blast, and keeps rolling. The tractor shudders with each explosion but maintains forward progress. When William completes the crossing, all 20 mines have detonated. The roller shows blast damage, but remains functional. The tractor is undamaged. William climbs out of the driver's seat, completely unharmed. The engineers stand in stunned silence. Finally, Morrison says, "That's the most ridiculous piece of equipment I've ever seen." "Does it work?" William asks. "It absolutely works. How fast can you build more?" "How many do you need?" Morrison does quick calculations. Normandy beaches have approximately 80 vehicle exit points that need clearing. Each exit requires clearing a path 300 yards long through suspected minefields. If we had 20 of these tractors, we could clear exits in days instead of weeks. "I can't build 20. I'm one person with a farm workshop." "What if we gave you help? Army mechanics, materials, manufacturing support?" William considers this. "I can train people to build them. Need 2 weeks per tractor if we work efficiently, so 10 weeks for 20 tractors." "We don't have 10 weeks. The invasion is coming." "Then give me more workshops. I'll design, you manufacture, build them in parallel at different facilities." Morrison makes an immediate decision. "You're hired as a civilian technical consultant. We'll set up production at 3 Army workshops. You'll supervise construction and train operators. Can you start immediately?" "I have a farm to run." "Your farm is supporting the war effort by producing food. This is also supporting the war effort. Which contribution is more critical?" William looks at the destroyed test field, thinking of his son Thomas, who will be landing on one of those beaches. "I'll need my daughter to manage the farm, and I want Thomas assigned as one of the tractor operators if possible." Done. For the next 5 weeks, William Fletcher works 18-hour days. He splits his time between 3 Royal Engineers workshops in southern England, supervising construction of modified tractors. The Army provides materials, mechanics, and manufacturing support. William provides design expertise, problem-solving, and quality control. The production process reveals challenges William hadn't anticipated. Challenge 1. Weighted rollers are difficult to manufacture. Each requires precision welding and careful balancing. Solution. William designs a simpler roller using multiple smaller drums welded together. easier to construct and repair. Challenge 2. Extended steering linkages create control problems. Operators struggle with delayed response. Solution: William adds intermediate linkage points that improve mechanical advantage and responsiveness. Challenge 3. Armor plating is heavier than expected, overloading the tractor's front axle. Solution: William redesigns weight distribution, moving some armor to the sides and using thinner plate on less critical areas. Each problem receives immediate attention. William's approach is purely empirical. Identify problem, test solution, implement fix, move forward. No committees, no lengthy analysis, just practical problem solving. By June 1st, 1944, 19 modified tractors are complete. They're officially designated Fletcher rollers in Army documentation, though soldiers immediately nicknamed them Fletcher's Follies due to their bizarre appearance. Each tractor requires 2 crew, a driver and a spotter who walks 20 yards behind, marking cleared paths and watching for mechanical problems. The drivers receive 1 week of training. The operation is simple. Drive slowly forward, let the roller detonate mines, clear a path. On June 4th, the 19 Fletcher rollers are loaded onto landing ships. William Fletcher, civilian consultant, is not allowed to accompany them to Normandy. Army regulations prohibit civilians in active combat zones. He watches from the dock as the ships depart, carrying his modified tractors and the soldiers trained to operate them. Among the operators is his son Thomas, assigned to drive Fletcher Roller No. 7. William returns to his farm, having done everything possible. Now he can only wait. June 6, 1944, D-Day. The Normandy invasion begins. The Fletcher rollers don't land on D-Day itself. The initial assault uses conventional mine clearance methods. Flail tanks, Bangalore torpedoes, and manual probing. Progress is slow and costly. By nightfall on June 6th, Allied forces control the beaches, but face the critical bottleneck: vehicle exits blocked by minefields. Armor can't advance inland. Supply trucks can't reach forward positions. The entire invasion force is compressed onto narrow beaches, vulnerable to German counterattack. June 7th, 7 a.m., the Fletcher rollers land at Omaha Beach. Sergeant Robert Hayes, commanding the Fletcher roller unit, surveys the chaos. Bodies, burning vehicles, discarded equipment, and everywhere, the white tape marking the narrow, cleared paths through minefields. "All right," Hayes tells his operators. "This is what we trained for. We need vehicle exits cleared by nightfall. Standard procedure: drive at 2 miles per hour, maintain 20-yard spacing between tractors, spotters mark cleared paths with tape." Questions? Thomas Fletcher, sitting in Fletcher Roller No. 7, asks, "What if the roller takes too much damage and fails?" "Then you stop, dismount, and report. Don't continue with damaged equipment. Better to stop than have the tractor itself detonate a mine with you in it." The Fletcher rollers spread out along Omaha Beach, each assigned to clear a different exit route. Thomas Fletcher's assignment: clear exit E1, leading from the beach to the village of Colleville-sur-Mer. At 7:30 a.m., Thomas starts his engine and drives toward the minefield. The weighted roller moves ahead of the tractor, pressing into sand still churned by artillery and littered with invasion debris. Within 30 seconds, the first explosion erupts. The roller bounces violently. Thomas feels the shock through the tractor's frame, but the armor holds. He continues forward. Another explosion. Another. The roller detonates mines at a rate of approximately 1 per 15 seconds. The cleared path extends behind him, marked by his spotter with white tape. After 30 minutes, Thomas has cleared 150 yards. Traditional manual probing would have required 6 hours to clear the same distance. Across Omaha Beach, similar scenes play out. 19 Fletcher rollers methodically work through minefields, detonating thousands of mines. The sound of explosions becomes constant background noise. By 2 p.m. 12 vehicle exits are cleared. Sherman tanks begin rolling inland, supply trucks follow, the bottleneck breaks, but not without cost. At exit D3, Fletcher roller number 12 takes a direct hit from German artillery. The tractor is destroyed. The driver, Corporal James Mitchell, dies instantly. His spotter is severely wounded. At exit F1, Fletcher roller number 4's weighted roller breaks apart after detonating 47 mines. The tractor cannot continue. A replacement roller must be brought forward, requiring 2 hours. At exit E3, Fletcher roller number 9 triggers a mine that detonates underground, creating a crater that swallows the front of the tractor. The driver escapes, but the tractor is inoperable. By nightfall on June 7th, the results are 23 vehicle. Exits cleared, 19 by Fletcher rollers, 4 by conventional methods. 2,847 mines detonated, 3 Fletcher rollers destroyed, 16 Fletcher rollers operational, 1 driver killed, 3 wounded. Estimated casualties avoided, 180 engineers who would have died conducting manual clearance. The Fletcher rollers succeed beyond expectations, but they face new challenges as operations expand. June 8-15, 1944. Allied forces expand the beachhead, requiring clearance of roads, fields, and villages throughout Normandy. The Fletcher rollers, designed for beach work, must adapt to new conditions. The problems multiply. Problem 1. Roads are mined with anti-tank mines that require more pressure to detonate than the rollers provide. Solution. Add additional weight to rollers using sandbags and steel plates. Problem 2. German forces begin targeting Fletcher rollers with anti-tank weapons, recognizing their importance. Solution. Provide infantry escort and operate rollers during limited visibility periods. Problem 3. Rollers wear out rapidly under constant mine detonations. Solution. Establish mobile repair workshops that fabricate replacement rollers from salvage materials. Problem 4. Some areas have wooden anti-tank mines that don't detonate from pressure alone. Solution. Attach chains behind rollers that drag across the ground, triggering wooden mines. Each problem receives field solutions developed by the operators themselves. The beauty of William Fletcher's design is its simplicity. Modifications can be implemented with basic tools and scrounged materials. Thomas Fletcher becomes the most experienced Fletcher roller operator. By June 20th, he's cleared 17 miles of roads and fields, personally detonating over 400 mines. His tractor number 7 is scarred by blast damage, but remains operational through constant field repairs. On June 22nd, Thomas receives a letter from his father. Thomas, I hear reports from Normandy about the tractors. They tell me you're doing well. I'm proud of you, not for operating the machine, but for surviving each day. The tractor is just metal and can be replaced. You cannot. Be careful. The invasion needs cleared paths, but I need my son home. Your father, William. Thomas keeps the letter in his pocket through the remainder of the Normandy campaign. July 1944. As Allied forces break out from Normandy, mine clearance becomes the critical enabler of advance. Roads must be cleared before armor can advance. Fields must be cleared before infantry can deploy. Villages must be swept before occupation. The Fletcher rollers work constantly. Army workshops produce replacement tractors as originals are destroyed or worn beyond repair. By late July, 38 Fletcher rollers operate across Normandy. The impact is measurable. Traditional mine clearance rates, manual probing. Speed, 15 square yards per hour per team. Casualty rate, 47% among clearance personnel. Path width, 8 feet. Reliability, high but extremely slow. Fletcher roller clearance rates, speed, 420 square yards per hour per tractor. Casualty rate, 8% among operators. Path width, 6 feet. Reliability, moderate. Mechanical failures common but repairable. The Fletcher rollers are 28 times faster than manual clearance and 6 times safer for personnel. But speed comes at cost. The tractors are brutalized by constant mine detonations. Average operational life is 40 hours before requiring major repairs or replacement. Some last longer through skilled maintenance. Others fail catastrophically after a single large mine detonation. The psychological impact on operators is severe. Driving toward known mines hour after hour, day after day, creates immense stress. Every explosion is a moment of terror, wondering if this detonation will be the one that penetrates armor, if this mine will be larger than expected, if this crater will swallow the tractor. Thomas Fletcher writes home in July. "Father, your tractor works, but it's terrifying. Every explosion feels like dying. The armor holds, but the noise is deafening. My hands shake when I climb out. Some operators refuse to continue after 3 days. I keep going because others need the paths cleared. I keep going because you built this machine to save lives, and it does. But it costs us something each time we climb back in." August 1944. Allied forces liberate Paris and push toward Germany. The Fletcher rollers continue working, now clearing the French countryside and preparing routes toward the German border. Production expands. British workshops build new tractors. American engineers request blueprints to manufacture their own versions. By August, 73 Fletcher rollers operate across France. William Fletcher, still working as civilian consultant, travels to Normandy in late August to inspect field modifications and gather feedback for design improvements. It's his first time seeing his tractors in actual combat conditions. The reality shocks him. The tractors are barely recognizable. Every machine shows extensive battle damage, field repairs, and improvised modifications. Some have extra armor welded on. Others have completely replaced rollers fabricated from whatever materials were available. Several have been rebuilt multiple times, with only the original engine and frame remaining from William's design. William meets with operators, including his son Thomas. The conversation is difficult. "Dad," Thomas says, "your design saves lives. I won't lie about that. But it's brutal on the operators. The noise, the constant explosions, the fear. Some men break down. Some refuse to continue. We've had 3 suicides among operators who couldn't handle the psychological strain." William hadn't considered this. He designed the tractor to protect operators physically. He didn't think about protecting them mentally. "What can I do?" he asks. "Not sure anything can be done," Thomas replies. "The job requires someone to drive toward mines. That's inherently traumatic. Maybe rotate operators more frequently. Maybe provide better psychological support. But mainly just build more tractors so individual operators don't have to do this every day for months." William returns to England with new perspective. His ridiculous tractor modification saves lives by keeping engineers away from mines. But the operators still suffer. The problem has shifted, not disappeared. September 1944, May 1945. The Fletcher rollers continue operations throughout the European campaign. As Allied forces advance into Germany, mine clearance becomes even more critical. German forces heavily mine retreat routes, roads, bridges, and strategic locations. By war's end in May 1945, the statistics are comprehensive. Fletcher roller production. Total units manufactured, 127. Units destroyed in combat, 43. Units worn beyond repair, 38. Units operational at war's end, 46. Operational statistics. Total miles of roads cleared, 327 miles. Total acres of fields cleared, 4,800 acres. Total mines detonated, 37,400. Total operator casualties, 11 killed, 47 wounded. Estimated engineer casualties avoided, 1,200, 1,600. Strategic impact. Allied advance speed increased 23% in areas where Fletcher rollers operated. Vehicle mobility restored to areas that would have remained impassable for weeks. Mine clearance bottleneck eliminated as constraint on operational planning. The Fletcher roller doesn't win the war, but it solves a specific problem at a critical time. Without rapid mine clearance, the Normandy breakout would have been delayed, potentially by weeks. German forces would have had more time to establish defenses. The war might have lasted longer. Casualties would have been higher. Thomas Fletcher survives the war. He operates Fletcher Roller No. 7 from June 1944 until March 1945, when accumulated psychological trauma forces his removal from clearance duties. He's reassigned to training new operators, a role he performs until war's end. After the war, Thomas never speaks about his mine clearance work. When asked about his military service, he says only, "I drove a tractor. My father built it. It did the job." William Fletcher returns to his farm in June 1945. The war is over. His contribution is complete. He expects to resume normal farming life. Instead, he receives a letter from the War Office. July 12, 1945. The letter informs William that he's been awarded the MBE, Member of the Order of the British Empire, for technical innovation and civilian contribution to military operations. The citation specifically mentions development of mine clearance equipment that significantly reduced casualties and enhanced operational effectiveness. The award ceremony occurs in October 1945. William travels to London, receives his medal from King George VI, and returns to Devon the same day. He doesn't enjoy the attention. He tells his wife, "I modified a tractor. Hardly deserves a medal." But the military understands what William doesn't fully appreciate. His ridiculous tractor modification saved over 1,000 lives. Engineers who would have died probing for mines instead lived because William Fletcher thought practically about the problem and built a simple, effective solution. Post-war, William returns to farming. He dismantles his workshop's military equipment and returns to repairing tractors and farm machinery. The Fletcher roller design becomes military property, used by British forces for another decade before being superseded by more advanced mine clearance technology. William Fletcher dies in 1963, age 72, of heart failure while repairing a combine harvester. His funeral in Barnstaple draws unexpected attendees. 47 former Royal Engineers who served as Fletcher roller operators. They travel from across England to pay respects. One of them, Thomas Fletcher, now a civil engineer living in London, gives the eulogy. "My father was a farmer who built tractors. During the war, he built one particular tractor that was ridiculous, ungainly, cobbled together from spare parts and farm equipment. Military engineers laughed at it. It looked like something a child would draw. But it worked. It cleared mines faster and safer than any official military equipment. It saved over 1,000 lives. It helped win the war." Dad never talked about it. He considered it a brief interruption in his real work, which was farming. But everyone in this room knows better. We were there. We drove his tractors. We're alive because his ridiculous design kept mines away from our bodies. The lesson I learned from Dad wasn't about engineering or tractors. It was about practical problem solving. He didn't design the perfect mine clearance system. He designed something that worked with available materials and could be built quickly. He prioritized effectiveness over elegance. That's the farmer's approach to engineering. Use what you have. Make it work. Fix it when it breaks. Don't wait for perfect solutions when good enough saves lives. Dad saved over 1,000 engineers. He never met most of them. He never sought recognition. He just built a tractor and taught us how to use it. That's who he was. The legacy of William Fletcher's tractor modification extends beyond World War II. His design influences post-war mine clearance technology development. The basic concept, using heavy rollers to detonate mines at a safe distance from personnel, becomes standard in mine clearance engineering. Modern mine rollers, used by militaries worldwide, descend directly from Fletcher's improvised design. In 1952, the British Army develops the Aardvark JSFU, Joint Services Flail Unit, incorporating lessons from Fletcher rollers. The system uses similar extended roller concepts with improved materials and engineering. In 1968, during Vietnam War, U.S. forces deploy the M58 MICLIC, Mine Clearing Line Charge System. While using different technology, the operational concept remains the same. Detonate mines remotely, clear paths for vehicles, protect personnel by keeping them away from detonations. In 2003, during Iraq War, coalition forces used modern mine rollers nearly identical in basic concept to Fletcher's original design. Heavy rollers extended ahead of armored vehicles, detonating mines before the vehicle crosses them. William Fletcher's ridiculous tractor modification has saved lives for 80 years and counting. The academic recognition comes slowly. In 1978, the Royal United Services Institute publishes a historical analysis, Practical Innovation in Military Engineering, Case Studies from World War II. One chapter covers the Fletcher roller. William Fletcher exemplifies practitioner innovation during wartime crisis. Without formal engineering credentials, Fletcher identified a practical solution to mine clearance that professional military engineers overlooked. His design succeeded because it prioritized 1. Simplicity. The Fletcher roller could be built with standard farm equipment and welding tools. 2. Repairability. Field repairs required only basic mechanical skills. 3. Effectiveness. The system cleared mines faster than any alternative. 4. Adaptability. Operators modified designs based on battlefield conditions. The Fletcher roller's limitations were severe. Mechanical reliability was poor. Psychological impact on operators was significant. Operational lifespan was short. By conventional engineering standards, the design was inadequate. But conventional engineering standards assume peacetime production with adequate resources and time. Fletcher designed for wartime reality, immediate need, limited resources, battlefield conditions. In that context, his inadequate design was far superior to theoretically superior systems that couldn't be deployed quickly. The lesson for military procurement. Crisis situations reward practical effectiveness over theoretical optimization. The perfect solution that takes 2 years to develop is inferior to the good enough solution deployable in 2 months. Modern mine clearance doctrine reflects Fletcher's principles. NATO training manuals emphasize mine clearance equipment must be simple, repairable in field conditions, and operable by personnel with minimal training. Complex systems that require specialized maintenance are tactical liabilities. In 2019, the University of Exeter completes a doctoral dissertation analyzing civilian contributions to military technology during World War II. William Fletcher receives a full chapter. Fletcher's achievement was recognizing that mine clearance didn't require sophisticated technology. It required applying existing agricultural equipment to a military problem. Tractors were designed to work in difficult terrain, handle heavy loads, and operate with minimal maintenance. These characteristics translated directly to mine clearance requirements. Fletcher's insight was that the military was overcomplicating the problem. They sought specialized military solutions when civilian agriculture had already developed appropriate technology. His genius was translation, taking equipment designed for farms and adapting it to battlefields. This pattern repeats throughout military history. Often, the most effective solutions to military problems come from civilian domains. But institutional barriers prevent cross-pollination. Military establishments prioritize military expertise, dismissing civilian practitioners as unqualified. Fletcher succeeded because crisis created opportunity. The Normandy invasion couldn't wait for proper military procurement. Desperate need opened doors that peacetime bureaucracy keeps closed. His tractor was tested because there was no time for committees and lengthy evaluation. The broader lesson. Innovation often requires crisis to overcome institutional resistance. Good ideas aren't sufficient. They need circumstances that force institutions to listen to unconventional sources. The final recognition comes in 2024, the 80th anniversary of D-Day. The British government announces that William Fletcher will receive posthumous public recognition for his D-Day contributions. A ceremony at the Imperial War Museum includes display of a restored Fletcher roller on loan from the Royal Engineers Museum. Attending are 3 surviving Fletcher roller operators, all over 95 years old, and William Fletcher's granddaughter, Sarah Fletcher, who traveled from Australia for the event. The museum curator reads a statement. William Fletcher represents thousands of civilians who contributed to Allied victory through practical innovation. His tractor modification cleared over 300 miles of mined beaches and roads, enabling the Normandy breakout and Allied advance across France. His design saved over 1,200 engineering personnel who would have died conducting manual mine clearance. Fletcher never sought recognition. He viewed his contribution as temporary wartime work, less important than his farming. But military records demonstrate that his simple, practical solution to mine clearance had strategic impact on the European campaign. The Fletcher roller succeeded because its creator understood farming, not warfare. He knew tractors, not military engineering. His outsider perspective allowed insights that military specialists missed. Today, as we honor William Fletcher, we also honor the principle he represents. Practical innovation comes from unexpected sources. Complex problems sometimes have simple solutions. The person best equipped to solve a problem may have no formal credentials in that field. William Fletcher was a farmer who modified a tractor. That modification helped win the war. Sarah Fletcher, William's granddaughter, addresses the ceremony. Grandfather died when I was 12. I remember him as a quiet man who smelled like engine oil and always had grease under his fingernails. He farmed until the day he died. The tractor modification was never mentioned in family conversations. I learned about it only as an adult, researching family history. When I read the military records, I couldn't reconcile the person described with the grandfather I knew. The records described innovation, courage, and technical brilliance. My grandfather was just a farmer who fixed things. But maybe that's the point. Maybe the greatest contributions come from people who don't consider themselves remarkable. Grandfather didn't think modifying a tractor was special. It was just problem solving, the same thing he did every day on the farm. The tractor happened to save over 1,000 lives because he applied farming logic to military problems. Use what you have. Make it work. Fix it when it breaks. Simple principles, enormous impact. I think grandfather would be embarrassed by this ceremony. He'd say he just modified a tractor, hardly worth making a fuss. But everyone who survived because of that ridiculous tractor would disagree. Sometimes the most important innovations come from the most ordinary people doing what they know how to do, just applied to unusual circumstances. That was grandfather, a farmer who knew tractors, who happened to save the Normandy invasion. The ceremony concludes with a moment of silence for the 11 Fletcher roller operators who died during the war, including 3 who survived mine clearance only to die in subsequent combat operations. The restored Fletcher roller remains on display at the Imperial War Museum, looking as ridiculous as William Fletcher's original design. An ungainly farm tractor with an extended frame, oversized roller and improvised armor plating. Museum visitors often laugh when they first see it. It looks absurd. It looks like something a desperate farmer might cobble together in a barn. It looks completely unsuited for military operations, which is exactly what military engineers said in 1944, before it cleared 300 miles of French coastline and saved over 1,200 lives. The story of William Fletcher and his ridiculous tractor is a reminder that expertise comes in many forms. William wasn't a military engineer, but he understood tractors, weight distribution, mechanical systems, and practical problem solving. Those skills translated to mine clearance when crisis demanded solutions. His design wasn't elegant. It wasn't sophisticated. It wasn't optimized. But it worked, could be built quickly, operated in battlefield conditions, and saved lives. Sometimes that's enough. Sometimes ridiculous solutions to serious problems are exactly what's needed. In June 1944, the Normandy invasion was bottlenecked on beaches surrounded by minefields. Engineers died trying to clear paths. The invasion schedule was threatened. The war hung in balance. A farmer from Devon modified a tractor in ways that made military engineers laugh. Then that ridiculous tractor cleared the minefields and opened the roads and enabled the Allied advance across France. Because William Fletcher understood that the problem wasn't complicated, it was just mines that needed detonating. And tractors are good at rolling over things, so he built a tractor that rolled over mines from a safe distance. Ridiculous idea. Worked perfectly. Saved the invasion. Sometimes the best solutions are the simplest ones. Sometimes the experts miss obvious answers because they're looking for complex solutions. Sometimes a farmer knows something generals don't. William Fletcher knew tractors. That knowledge saved the Normandy invasion. His legacy is a reminder to listen when practitioners offer simple solutions to complex problems. Because sometimes, just sometimes, the ridiculous idea is the right one.